And welcome once again. I'm Olunlade Joshua and this is the fourth video in this tutorial series, Fluid Mechanics, Liquids in Motion. Today we are going to be studying energy of a flowing liquid. The energy of a flowing liquid. Now, a flowing liquid can have three forms of energy, can possess three forms of energy, and they are potential energy, pressure energy, and kinetic energy. Now let's look into this with a bit more detail. Potential energy. Why would a fluid have potential energy? It has potential energy because of its elevation above datum level. If the weight of a fluid is W and the height of the fluid above datum is Z, then the potential energy is given by Wz, and the potential energy per unit weight, basically you divide this by W. The potential energy per unit weight is Z. This is also known as the potential head. Potential head. Z is also known as the potential head. It is the potential energy per unit weight and it is also known as the potential head. Pressure energy. When we say pressure energy, this is the energy of a fluid flowing under pressure. When a fluid flows in a continuous stream under pressure, we know that it can do work, right? So if the area of the cross section, is A and the force is PA, force due to the pressure P on the cross section is PA, and if the weight is W, we know that volume passing through the cross section, W, will now be equal to W over W. That is weight over specific weight. And how do we get this? Let me just quickly explain. We know that force is equal to specific weight times volume, W times V. This is specific weight and this is volume. Force is equal to specific weight times volume, and easily this force can be replaced with the weight of the column. It's equal to W over WV, and then volume will now be equal to W over W. I hope it's clear. So now I'm going to erase that because that is just an explanation. So the volume passing through the cross section is this, W over specific weight, and the distance moved by the liquid will be weight over the specific weight times area. It makes sense because we know that volume is area times distance. So if we want to get distance, that will just be volume over area. So that is this times A, basically. I hope it's clear. And then, so now we can have the work done, which will be force times distance. Force, which is PA, times distance, which is given by this expression. And when we have this, A cancels A, and then we have the expression W times P over W. So therefore the pressure energy per unit weight is P over W. That is pressure over specific weight. This is also known as the pressure head. P over W is also known as the pressure head. Note that. This is also known as the pressure head. Now, on to kinetic energy. If the weight W of liquid has a velocity v, then we know that kinetic energy Ke, if you remember from physics, is given by the equation 1 over 2 mv square. So easily we can get the kinetic energy of a fluid, which will be basically 1 over 2 the mass of the fluid times its velocity, and that will give birth to this equation. This is m, mass is equal to weight over acceleration due to gravity. So that is the kinetic energy, and the kinetic energy per unit weight is v square over 2g. Now there is something called the velocity head, and this is also known as the velocity head. It is the kinetic energy per unit weight, and it is also known as the velocity head. So the total energy per unit weight is z plus p over w plus v square over 2g. That is the the potential energy per unit weight plus the pressure energy per unit weight plus the kinetic energy per unit weight. You know that this is the potential head, this is the pressure head, and this is the kinetic head. So let's quickly take an example. Water at an altitude of 36 meters above sea level has a velocity of 18 meters per second and a pressure of 350 kilonewton per meter square. Calculate the total energy per newton of this water reckoned above sea level. So now, as I said, problem thinking. I want you to be thinking, not just cramming. What were we asked to calculate? We were asked to calculate the total energy per newton of this water reckoned above sea level. So basically, we were asked to calculate total energy. Total energy. We do not know the total energy. So now, what do we know? We know the formula, but from the previous slide, we know that the total energy per unit weight. Let me write it. Total energy per unit weight is equal to Z, that's the potential head, plus the pressure head, which is P over W, plus, let me write that plus properly, plus V square over 2G. What are the things? So this is the equation we know now, and we're asked to find the total energy per unit head. So what are the things we're given from the question? We're given the height above datum level, that is Z, 36 meters. So datum level is sea level. The height above datum level is 36 meters, and we're given the velocity v, 18 meters per second. We're given the pressure P, 350 kilonewton per meter square. So now the total energy per unit weight will be equal to Z 36 plus P over W, which will be 350 times 1000 over W. And what is W? W is 9.81 times 10 raised to power 3. 9.81 times 10 raised to power 3. And you wonder, how is it 9.81 times 10 raised to power 3? I would explain that later. And then plus V square, that is 18 square over 2G, 2 times 9.81. And putting this into my calculator, the answer is 88.2, and the unit is Newton meter per meter. You can wonder, why didn't I just write, sorry, Newton meter per Newton, not per meter. Newton meter per Newton. Some people write it like this and some people just write it in meters. It is the same thing as 88.2 meters. And now, how is W 9.81? W is 9.81 because if you remember the formula, W is equal to rho G, and generally G is 9.81 meters per second. Now W will now be equal to rho into bracket 9.81. So in that case we used water, so therefore the density of water is 1000, so that is times 9.81, which makes W to be equal to 9.81 times 10 raised to power 3. Thank you for watching this video. I hope you understand it. If you don't, you can go over it, do more research, just make sure you understand it. That is why I've made this video. Please comment below if you have questions, or just let me know your mind in the comment section below. I am Olunlade Joshua. Please subscribe to this channel for more updates and videos, and I will see you in the next video. Bye.